Hey, this is the video for 14.3, the translations or slide, or this textbook also called grides. Okay, now this is the, I'm asking you to move this equation up 3 and right 4. Okay, so I want you to try that here. And then we check how you did after we finish the video. Okay, so try it right now. And then we want to check your your answer for equation afterwards. Okay, alrighty. And objective for this one is locate image of figures by translation, which is a slide or gride. Those are colloquial words. Okay, I'm putting the parenthesis the colloquial words so you can remember what they are. Okay, all right, so translation, glide or slide. Transformation that glides all points of the plane the same distance in the same direction is called translation. Okay, so A goes to A dash, and then it went 3, right 3 and 1 up, right 3 and 1 up, right 3 and 1 up. So these are translations because the vectors of these moves are all the same. If a transformation maps A to A dash and B to B dash and C to C dash, point ABC glide along the parallel or collinear segments, and A dash equal B dash equals C dash. Any of the vectors, vector A dash, vector B dash, or vector C dash, could describe this translation. Okay, so the translation can be described by the vector. Just like in the warm-up, I told you to go like up 3 and left whatever I asked, I forgot. Anyway, each vector has the same magnitude. The magnitude is this. You remember this distance right here, which is the distance formula of this and this. So it's 1 square plus 3 square, or root 10. And each vector has the same direction as indicated by its slope of 1/3. Note that we don't need to know the coordinate of point ABC to describe the translation. Okay, so translation is like a vector. You don't know what, it doesn't matter where you start. Okay, what matters is the direction, which is in this case the slope, and the distance, the magnitude. Okay, so consider a translation in which every point glides 8 units right and 2 units up. We could use the vector A2 to illustrate such a translation, or we could use the coordinate expression t for transformation of x and y goes to x plus 8 and y plus 2. The following diagram shows how triangle PQR is mapped by T translation to triangle P dash Q dash and R dash. You can use the distance formula to check that such segment is mapped to a congruent segment so that T is isometry. Now you remember we already did the reflection, right? And the reflection we had here like L, reflection over the axis of symmetry, and then like a T goes to T dash. That was the expression for reflection. So translation shows like this. Okay, so the translation, T is for translation. Okay, so here negative for 1 went to 4 and 3. So plus 8 and plus 2. Here, negative to negative 2 went to 5 and 6 and 0. Plus 8 and plus 2. And this point, 1, 6 went to 9 and 8. Plus 8 and plus 2. Now I want you to check the distance of here. Just do this and this, okay? And see if it's the same. And I don't need you to do all 3. Okay, so just check this distance and distance if it's the same, okay? The illustration just presented should help you understand why we use the following definition of translation when working in a coordinate planes. A translation or glide in the plane is a transformation T which maps any point xy to a point x plus a, y plus a, and a and b don't have to be the same number as long as they are constant for each point that moves. Okay, so the a and b doesn't change. So this point, this is A, and this is B. this is A and this is B. As long as the A is the same and B is the same, A and B don't have to be the same number for it to be translation, and as long as you follow the rule, the transformation is isometry. So here, the coordinate x1, y1 went to x1 plus A and y1 plus B, and x2, y2 went to this. And plan of proof, label 2 points, and their map as shown as a diagram to show that is isometry. We need to show that PQ equal P dash Q dash. Use the distance formula to show that. So I want you to try this. If you can make, using these coordinate and these coordinate, if you make these, you can make these the same, okay? Instead of using the numbers, now you have to use A and B's. Okay, so try that, that's homework. And since translation is isometry, the corollaries work, which is the translation preserves angles and areas. Okay? All right, and here is the glide, reflection, or slide flip. So glide and reflect, or slide and flip, or flip and slide. It doesn't matter which it goes. So here, this is translation and reflection, and translation again, and reflected. So that's a glide flip. Okay, so it's gliding here and reflecting over this line. Okay, so that's a combination of reflection and translation, and that's also isometry. Okay, you remember when we did the Venn diagram that I told you the translation and reflection have an overlap here, right? So this is T and this is R, and this is glide reflection. Okay, I don't know why you call this glide reflection instead of translation reflection. Maybe it's just too long. Anyway, or slide flip. All right, so let's do some practice. Okay, all right, complete each statement for translation. T of x and y goes to x plus 3 and y minus 1. So the T glides points whatever unit's right and 1 unit whatever. Okay, so to the right 3 units, right? To the right 3 units, and 1 unit, this is negative, so it's down. Okay, and image of 4, 6 is, so you put the 4 and 6 in here, so you have 7 and 5, and put image of 2, 3. Now x plus 3 is 2, so x have to be minus 1, and y minus 1 have to be 3, so y is 4. Okay, not bad. Describe each translation in words as in exercise 1a, and give the image of 4.6, 4,6, the coordinate 4, 6, and the pre-image of 2, 3, so it's the same. Okay, so you try these for homework. Okay, just repeat what we just did here. And each diagram shows a point P on the coordinate plane and its image of P dash. Enter the translation to complete the statement on this. Okay, so you can do, well, I want you to do all 3. Homework, all 3. Okay, so just write this. Just identify what kind of translation these are by writing those under each of them. Okay, and for a given translation, the image of the origin is 5, 7. What is the pre-image of origin? Okay, so what this means is that after you do the transformation, the origin became this. So, using the same transformation, what is the pre-image of origin? Are you confused? All right, from origin to this image 5, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay, so this is the transformation, right? Translation. This went over here. So what is the pre-image of origin? So it's gonna go back this way. So you're gonna go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. This is the pre-image of origin of this translation. Okay, a glide reflection has a glide translation of this, the line of reflection is line M, which is equation y equal x. Okay. So that's one of your favorite, right? At this point, I hope. So this is y equal x. Okay, so you have to do this translation, which is 2 and 2, and then you have to flip it. Find the image point S dash of S under T. The line grid has translation T, and the line of reflection is line M with equation. So this is M. Okay, so let's try this one. So -1, 3, -1 and 3. This point is first you're doing translation. Now, if you do reflect and translate and reflect, or translate and reflect, you get to the same place? I think these you can do in the same order. Let's try it. I know that the rotation and translation you cannot do in the if you flip the order, you get to the different place. But translation and reflection, I think you get to the same place. All right, so let's try it. So this is right to and up to. So right to and up to, you go over here, right? And then now you have to reflect over here. So this point is 1 and 1, 2, 3, 4, 5, 5, right? So if you reflect over y equal x, you flip x and y. So you're gonna go 1, 2, 3, 4, 5, and 1. So if you connect these 2 points, this is perpendicular bisector, right? So this is the end point of A, which is 5 and 1. Okay, now let's try reflect first and then do 2 and 2. Okay, so this point is -1 and 3, right? So it's gonna go to 3 and -1 over here. So if you connect these 2 points, this is perpendicular bisector. And then do 2 and 2. Yeah, you get to the same place. Okay, find the image of point S dash dash of S under reflection M. Oh, we already did that. Recall from the example page, the reflection M is, yeah, the flip X and Y. We already did the B. Okay, so this was A and this was B. Sorry. But if under the grid reflection XY fast map to, under the grid reflection XY is fast map to 1, 5, and then onto 5, 1. Okay? All right. So I'm going to make you do one of these for the video solution. And I think I want you to do one of grid reflection one, like these. So you do both, okay?